In this video, we're going to look at the same things that we looked at before, but this time we're going to change those numbers from scientific notation back to standard form. You can stop on this slide if you need to review those definitions. So a penny weighs 2.5 grams on the Earth. On the Moon it weighs 4.15 times 10 to the negative first grams. Our goal this time is to change numbers from scientific notation to standard form. So what we're going to do is we're going to copy down 4.15, and I like to write it to the right side because I know when I have a negative exponent that I'm going to move the decimal to the left. So a negative exponent shows us that we're going to move this decimal to the left. We know that we're going to move it one time because it's a -1. So I move the decimal from here one time to the left, and the decimal is now going to be right here. So the new answer is 0.415 grams. So the weight of a penny on the Moon is 0.415 grams. On Mars, a penny weighs 9.43 times 10 to the negative first grams. I'm going to write down the 9.43, and then I'm going to look at this exponent. The exponent is negative, so I know that I need to move the decimal to the left, and I should move it one time to the left. So I'm going to take this decimal, move it once to the left, and my new answer is 0.943 grams. That's the weight of a penny on Mars. All right, let's look at the goose feather weights. So first of all, we need to change 1.25 times 10 to the negative third to standard form. So I'm going to write this 1.25 over to the right. And then I look at this exponent. The exponent tells me to move the decimal to the left. And I know I'm going to move it 3 times to the left because it's a negative exponent. And because the exponent is 3. So I move the decimal 1, 2, 3 times to the left. We're going to put in 2 zeros to hold the place value because we moved it 2 places, the decimal 2 places past the 1. So 0.00125 pounds is the weight of a goose feather on Earth. If you want to put those units in there, you can. In B, we're looking at the weight of a goose feather on Jupiter. So in scientific notation, it says 3 times 10 to the negative third. I'm going to write the 3 over here to the right. I'm going to write in where the decimal was originally, and then I know that since this is a negative number, we're going to be moving the decimal to the left, and we're going to move it to the left 3 times. So we move it 1, 2, 3 times to the left, and I need to put in 2 zeros to hold the place value. So my final answer here is 0.003 pounds. That's the weight of the goose feather on Jupiter. And then finally, the weight of a goose feather on Saturn. We start out with 1.4 times 10 to the negative third. So I'm going to write the 1.4. And then I know that I move the decimal to the left 3 times because the exponent is a 3. And because we know we're going to move it to the left because of the negative symbol. So I start the decimal here, and I move the decimal to the left 1, 2, 3 times. And I moved it 2 places past the 1, so I need 2 zeros to hold the places. So my final answer is 0.0014 pounds. That's how much the goose feather weighs on Saturn. Alright, time to talk about the dogs and how much they weigh on Pluto. So let's look at the let's look at the poodle first. So we start with 8.71 times 10 to the negative first. We copy down the 8.71, that first part, and then we know that we're going to move the decimal to the left because of the negative symbol. We know we're going to move it once to the left because of the 1. So let's go ahead and do that. We move it to the left once, and you see that on Pluto, an adult poodle weighs 0.871 pounds. Now let's go ahead and deal with the Yorkshire Terrier's weight. It starts out as 4.69 times 10 to the negative first in scientific notation. Then we're going to copy down just the beginning portion, 4.69. We know that we're going to move the decimal to the left because of the negative symbol. We're going to move it once to the left. We know that because of the 1. And we're going to go ahead and move it to the left one time, and we get 0.469 pounds. That is the weight of the Yorkshire Terrier on Pluto. And then last but not least, we're going to talk about the cheetah. On Earth, a cheetah weighs 6 times 10 to the negative second tons. So we're going to start out with the 6. We know to move the decimal to the left because of the negative symbol on the exponent. We know we're going to move it twice because of the 2. So the decimal starts here to the right of the 6, and then we move it to the left once, twice, and we put in a 0 because we moved to the left once past the 6. So we need the 0 to hold that place value. So 0.06 tons is the weight of a cheetah on the Earth. On Pluto, the cheetah weighs 4 times 10 to the negative third. Copy down the 4. And we know that we're going to move to the left because of the negative symbol. We're going to move 3 times to the left, we know because of the 3. The decimal starts to the right of the 4, and we move the decimal to the left 1, 2, 3 times. And we plug in 2 zeros. So 0.004 tons is how much the cheetah weighs on Pluto. Finally, on the Sun, we write down 1.624, and we don't move the decimal to the right or to the left because the exponent is 0. So the final answer is 1.624. You don't really have to do anything. So the cheetah weighs 1.624 tons on the Sun. And we've gone through all of the examples.